Welcome back, algebra friends. For our last part for this section is we're going to try to figure out how to go from what we knew before as vertex form into our new form that we call standard form. Meaning, how do we go from something that looked like this, y equals ax minus h squared plus k, into something more like this, y equals ax squared plus bx plus c. Visually, it just looks like we got rid of the parentheses and the H and K's somehow turned into B's and C's. I don't know. Well, the best thing to do, looking example part A, is let's just simplify. So the first step usually is we want to FOIL the parentheses here on part B or on part C. That's always the first step. Step number one is FOIL. All right, let's try that with the first one. So I want to get rid of the parentheses so it starts to look a little bit more like standard form. Here we go. So when I'm FOILing, I'm thinking this. X minus 2 squared is really x minus 2 times x minus 2 plus 3. And FOILing just says let's multiply our firsts, our outers, our innards, and our lasts. So that would be x times x, okay. Negative 2 times x is a minus 2x. And again, the innards give me negative 2x again. And last, negative 2 times a negative 2 is a positive 4, and then the positive 3 on the outside comes back into play. And now we just simplify, keep going. So after you FOIL, step 2 is just simplify. Meaning get all your like terms together and make it look a little bit more like it's in standard form. Okay, so let me bring those two negative 2x's together and I get x squared minus, that's 4 of them. And then the plus 4 plus 3 is plus 7. And I'm done. That's the same parabola that we started with up here, but now in standard form. And interestingly enough, the vertex here would be 2, 3. And if we did negative b over 2a, I guarantee we would get 2, 3 also. Great. All right. So that's generally how these go. If you want to try B and C on your own, and then check back with me and we'll see if we got the same answer. Go for it. Pause the video. Give B and C a try, and I'll see you back here in a minute. All right, first step here is I'm going to rewrite it so I can see the FOILing. That's really what x plus 1 squared looks like. Okay, and I FOIL, and I get, I'm going to go ahead and take the extra step and FOIL, but then also simplify. So I know I have 1x, and then I have another 1x, so I'm just going to jump ahead and say I have 2x. Okay, by PEMDAS, I have to multiply next. So the negative 2 gets to play with everybody, and then negative 2 that was hanging on the outside. So after bringing everything together, I get negative 2x squared minus 4x minus 4. And that's my final answer for part B. How'd you do? Not too bad, right? It's just doing extra algebra steps. But we're changing from one form that has the vertex form into a more standard form. All right, part C, last one. I'm going to rewrite it so I can see the FOILing. And then plus 1. Okay, I'll do the same thing where I'll just FOIL it now, and I'll show you my final answer. Multiply through. Some big numbers there, huh? And then plus 1 at the end. And here's your final answer after I simplify. Did you get 3x squared minus 24x plus 49? And just to show you before you run away why this is really, really cool. Up here, if I try to figure out the vertex, and we know that in vertex form it's h, k, here it'd be positive 4, positive 1. That's our vertex. We feel really good about that. But if I wanted to, just for the heck of it, try to figure out the vertex when it's in standard form, we need to do the negative b over 2a, which is the axis of symmetry, and it's the x-coordinate of our vertex. Okay, well, in my final answer, b is negative 24, so negative b would be a positive 24. A here is the positive 3 in the front, so 2 times a would be 6. 24 divided by 6 is 4. That's looking good because down over here we saw 4. And then how would we get the y value? We could just plug it back into here. And if I plug in 4, a lot of things cancel, and I get 1. So my vertex would be 4, 1. That's a good way to check. Did I get this right after all the foiling? Yes, we did. The vertex matches from either vertex form or standard form. And that's, folks, how we can go from one form really easily to the other. Great job, and we'll see you next time.